First, you need to prepare black paper, water, dishwashing liquid, plate or bowl. First, pour water into a plate or bowl. Then, shake some pepper onto the water. If you dip your finger into the paper and water, nothing much happens. If you put a drop of dishwashing liquid on your finger and dip into the paper and water, the paper will rush to the outer edges of the dish. How the pepper and water trick works. When you add detergent to water, the surface tension of the water is lowered. Water normally budges up a bit, like what you see when you look at the water drop. When the surface tension is lowered, the water wants to spread out. As the water flattens out the dish, the paper that is floating on top of the water is carried to the outer edge of the plate as if by magic.
First, you need to prepare 2 beakers, a paper with 2 different direction arrows and a paper with reverse words. First, we need to put the paper behind the beaker in a certain distance. Then, pour the water into the beaker. As we can see, the first arrow turned to the opposite side. Then, we continue to pour in the water. The other arrow will also change its direction. First, we need to put the paper behind the beaker in a certain distance. Then, pour in the water into the beaker. As we can see, the reverse words will turn back into normal, which is optical inversion. In the experiment, we know that the arrow and words will change their direction after pouring the water into the beaker. So, what's actually going on? Actually, this is demonstration of physics concept called refraction, the bending of light. When light passes from one material to another, it can bend or refract. In the experiment, light traveled from the air, through the glass, through the water, back to the glass, and then back through the air before hitting the arrow. Anytime the light passes from one medium or material into another, it refracts. As a result, the arrow and words will change their direction.
First, put a water bottle in the freezer and put it for 2 hours. Now, take out the water bottle after 2 hours. Take it slowly and don't shake it. And you can hit the water and you can see the water turning to ice. This is also referred to as super cool water. Everyone knows the freezing temperature of water is 32 degrees Fahrenheit or 0 degrees Celsius. When this temperature is reached, the water molecules freeze by forming ice crystal. It's easier for the water molecule to turn to ice on top of already formed crystal.
First, we need to prepare a glass, a bowl of water, and some oil. First, we need to pour the water into the glass. Then, add in the oil into the glass. As we can see, the oil can't mix with the water. As we can see in the video, the oil can't mix with the water. So what is actually happening? First, oil and water have different densities. Water is denser than oil. Thus, when water and oil is mixed together, water will always sink underneath the oil. Second is because polarity. Water is a polar molecule. Polar molecule will only dissolve in polar solvents. Similarly, non-polar molecules will only dissolve in non-polar solvents. Oil is made up of non-polar molecule. Therefore, even if stir a container with oil and water, they will eventually separate into two distinct layers.